Today we're
Sorry, I just started
no
recording.
worries, no worries. So today we're going to dive deep into Docker, and we have Guy and Parham here. We are with Data Stack Academy, and we are launching a boot camp January 3rd that will teach you how to be a data engineer, and we even place people in wonderful internships. So today we will get into Docker, and if you have any questions, feel free to put it in the chat function. If you have questions after we get finished with this presentation, then feel free to email me. My email is in the chat. And I guess without further ado, I'll bounce it over to you guys.
Thanks a lot, CJ. Yeah, appreciate
Thanks,
it.
CJ.
Yeah. So on this side, we have Guy and Parham. We're with Data Stack folks. So as CJ said, we're going to take you guys through Docker today. And Docker is a technology that's been very well known these days, and it's pretty much fundamental on anything you're going to do on cloud and just in software deployment is in general. So this is going to be a very hands-on demo, and I'll let Guy kind of kick us off.
Yeah, so just to give you a brief overview, we're at Data Stack, we're data engineering focused. So we're going to talk just a little bit up front about what data engineering is and why it's a good opportunity right now, and a little bit more about data engineering as a career. And then the real meat of the presentation is the what, why, and how of Docker. We're going to talk about what Docker is and what tools it provides to us. Then talk about why we use it, the motivations behind containerization technology, and why the adoption of Docker has been so widespread in recent years, why it's made such an impact on software deployment, application deployment, and data engineering. And then we're going to give you a kind of an extended hands-on demo of how Docker works with some different command line things, and so you can see in practice how we actually use Docker and what that looks like. And then we'll tell you a little bit more about Data Stack Academy and the resources that we have available, so you can know a little bit more about our course and know how to find out more if you have questions.
Thanks, Guy. So really quickly on data engineering as a whole and data engineering market, we've all heard about data, and data is the future. There are some very hard numbers behind saying that data engineering is the fastest growing field in tech and is the best place to be in tech. So some of these numbers that we're going to show you, the top one is from Butchworks. This is from summer of 2020 to summer of 2021 report. So middle of pandemic. They interviewed 320 companies, and out of the 320 companies, 81% said they hired data engineers in that year. That's incredible. Right now, and these, again, we're going to post these numbers. We're going to post the sources for these numbers after the presentation. But the second number there is public. You can just go and see that is 100. Average salary for a data engineer right now is on Indeed is 119K per year, and there's 40,000 open jobs on data engineer on Indeed. Again, go and look at it yourself. That is higher average salary than any other field in tech, higher than data science right now, higher than full stack developers. And the reason is because there's so much demand for data engineers, and there's just not enough of those data engineers out there. The last number, I think, is the most interesting one, the 50%. That's from Dice Reports. Dice, very well accredited reporting agency. In again, 2020, they analyzed 6 million job postings, 6 million job postings, and data engineering was the fastest in that market. It almost doubled the next one as far as the 15% growth. The next one, I think, was 36%. And it almost like doubled the last one on that report. The last stat there, which is amazing, it is listed on Indeed, and it's saying that data engineering is, I mean, one of the benefits of data engineering is that you get unlimited time off. I don't know what that means. Sounds great, but it's listed on Indeed right now. So let's get into Docker. I mean, that's why we're here. We've all heard a lot about Docker. Docker is a containerization tool, and you might have heard that. Very generalizing, we can say Docker is a virtualization containerization tool. What is a container? When you think of a container, you can think of a container as same as like a moving container. You know, something that you get, and you get to pack it with all sorts of stuff. You get to put your code in there, you put your application in there, for different software in there. And the great thing is that you can ship this container, just you ship like a normal like moving container or shipping container. And the guarantee is when it arrives at the destination, it's exactly the same thing that you ship. So you can ship like your software and code to someone else, to the cloud, to your friend, to your coworker, and it's guaranteed that will run exactly the same as it ran on your computer over there without any problems. So containers are a way to standardize software deployment. It makes it very easy for you to pack software and then deploy that anywhere. And it makes it very easy so that your deployment is agnostic of where it's being deployed. So that again, it's very easy. I don't know, Guy, how many times like before in your career you had to worry about how you ship software to someone, and if they have all the dependencies,
so much work involved with changing platforms, and it used to be very different before Docker was around.
Exactly, and all of that is gone. So like as long as you pack it in Docker container, you're guaranteed that that code will work anywhere, just the same as it did on your machine. Some of the terminologies that we're gonna discuss here. Well, first you have to install the Docker engine. So that's the engine that guarantees these containers run on any machine or on the cloud. There's also this concept of Docker Hub. Docker Hub is where it's like a central repository that Docker hosts. You can also host it privately, that has these containers that you can load these containers, and then other people can go download them from there. There's some of the other terminologies that you would hear is Docker image. So image is like the blueprint for the container. Image is that source. And the container is a running instance of that image. When we typically see a Docker container, it's a running instance of that blueprint or that image. We also have the concept of volumes, Docker volumes. This is very interesting because by design, Docker is meant to be transient. So when a container runs and when it finishes running, it just vanishes. And that's good. That's actually really good for testing, because a lot of times you want to kind of spin off a container, mess around in development phase with other things, see if things work. If they don't work, you can shut that down and nothing happens. You can just spin off another one. If you mess that one up, you can just start from the beginning.
And this is one of the amazing things about Docker, because obviously a big part of that motivation is to isolate the code from its environment, which the Docker engine helps us do that. But it also provides us the ability to interact with system volumes and to have persistent data. So it's like getting the best of both worlds. It's exactly really kind of amazing.
So the volumes is to give persistency to the containers. Yeah. So the volumes, Docker, you can persist the data. So in between the container runs, you can kind of come back when you left off. That gives you that persistency. There's the concept of Docker file. Docker file is like it's a text instructional file, which you'll see later, that is the blueprint. That's how to build the image. So it tells Docker, this is the instructions to build this image. It's very nice because it's layers and you can base yourself off a previous image. So you can kind of build things like a Lego set. You can just put layers on top of each other. There's the concept of Docker Compose, which again, you will see here. Docker Compose is very good. Now, you get into a scenario where an application is more complex to just be one Docker container or one Docker image. Let's say you have something that has a database element to it, that has like some data loader element to it. It has a data cleanser element to it. It has like a REST API. It has, instead of packing all these different pieces into one giant Docker container, you can maintain them separately, and you can have a Docker container per each one. And that is called actually microservices. If you hear microservice-based architecture, that is it. That is how you separate out each one of these elements into their individual containers. And it's make it easier for you to maintain each, to upgrade each, to troubleshoot each. And Docker Compose is a way to organize or orchestrate launching on all those at the same time. So Docker Compose can launch all these containers at the same time, make sure they're all running, they can all talk to each other. In a way, Docker Compose is the JV league of Kubernetes. It's like if you played sports, that's kind of like your JV league. Kubernetes takes that concept and it's just the varsity level now, where you have millions and thousands of these containers that need to be orchestrated. And that's what actually all the cloud companies kind of run behind the scene.
Yeah, when you see applications, things like Google Web Search that are deployed at huge scale and ultra reliable, a lot of times those are probably running using Kubernetes or some kind of container management orchestration, because it just otherwise it would be really difficult to deploy and manage things at that scale. But the containerization engines make that a lot easier and more possible. Okay, so let's look a little bit more at the why of Docker and why Docker's become so influential, why it's changed the world of software so much, and we'll go a little bit more into the details of some of the things that Parham just talked about. So at the most basic level, containers are yet another solution to the problem of complexity in software development. As Parham was saying, it used to be when you develop an application on one platform, there was a lot of time and energy that you would have to spend adapting it for other platforms. You're dealing with different versions of compilers and different sets of dependencies, and maybe packages aren't available on another platform. And these first 2 points, fast deployment and running anywhere, are related to each other, and they're related to that issue of the motivation of making code more portable. That tedious work of getting applications to run on different platforms is something that Docker solves really, really well. And it's a reason why Docker containerization technology, and Docker in particular, has become so widely used. So containers are in some ways similar to another technology you might have heard of called virtual machines, but containers have some special advantages. So with a virtual machine, you're also packaging code with configuration files and other dependencies, but you're also packaging a whole guest operating system. Whereas with a container, containers are more lightweight and more efficient because you're not packaging with that entire separate operating system. And so in terms of efficiencies, how many containers can run on a particular server, containerizations have huge advantages, and they also have a big efficiency advantage in terms of developer time and just making it easy to deploy software and manage those deployments. As Parham mentioned, containers are great. Docker's great because they're cloud and platform agnostic. Once you have the container set up, you can deploy it not only on any operating system, any platform, but on any of the major cloud vendors. All have their own implementations of Docker and letting you run those containers. So it makes it super easy, no matter what the details of your exact deployment are. And the ability to run code like this uniformly and consistently across different platforms is just, it's hard to overstate the benefits of that. I mean, it makes it so much easier to automate and manage your deployments. If you've ever heard the term CI/CD, which stands for continuous integration, continuous deployment, Docker containers are a big part of why that model has become dominant in software. Another big advantage with containers is fault isolation. So when you have containers like this that are independent from each other, if you have some software deployed, you have multiple containers running, and there's a problem with one of those containers are isolated from each other. So the development team, the development operations team, can address the issues with that one container without affecting the others, and that's another big advantage. Containerization is something that's been around for a long time in the industry, but Docker, came on the scene in 2013 and made just a huge splash, and the adoption of Docker technology has just become ubiquitous. It's hard to overstate how much it's changed the industry.
Yeah, exactly. Yeah. The fault tolerance is what Kubernetes helps a lot too, right? So like when one container fails, Kubernetes immediately spins off another container for you. And
yeah, and as Parham mentioned, Kubernetes is kind of like the next level of containerization technology. The ability to manage and orchestrate large numbers of containers and have that process be automated, have your cluster scale up, have it manage when a container fails and replace that makes it possible to achieve a level of performance and reliability that really wasn't possible before containerization. So there's a lot of reasons why containerization in general and Docker in particular have really taken over the world of software development, software deployment. As data engineers, it's a tool we use all the time as well. So if you're interested in data engineering, this is something that will be a part of your day-to-day work. And let's talk a little bit more about the Docker workflow and what that actually looks like in practice day to day. So Parham already talked a little bit about the Docker Hub, which is the place for everything Docker, where the action all starts and happens. Docker Hub is a great community resource that has a repository for existing images. So when you're just getting started with Docker, you can pull images from Docker Hub. There's just millions of them available, applications that people have already packaged in container form that you can download the images for. So you can do a pull to download an image locally and have your own working copy. When you run that image, it becomes a container. As Parv said, that a running instance of an image is called a container. So Docker Engine, Docker Hub make it really easy to download software that's already been built by others in the community and immediately run that on whatever your platform is. Then if you're interested in making your own contributions and your own changes, Docker Build will let you, add other things, code files, configuration files, modify existing images, or create your own from scratch with whatever code that you need and whatever dependencies that you need. And then when you have an image of your own that you've developed, modifying it or making your own, you can do a Docker push to put that image back into Docker Hub, the image repository, and make it available to others. And the Docker Hub and Docker Engine make this workflow really easy and straightforward. They make it really easy to use things that other people have built and to make your own contributions to the community. And so this combination of tools is yet another reason why Docker has made such an impact on the world of software.
Which we're going to show that now.
Yeah, now we're going to give you a hands-on demo so you can see where we're talking about.
All right, so let me start by showing you Docker Hub here. So this is Docker Hub. This is the central repository Docker host for all the Docker images that are out there. And pretty much any software that you want to have run on your machine now, first thing, go here and see if there's one of those. You don't need to install anymore. Like if you want a MySQL engine, we type MySQL, and there's plenty of versions of MySQL or MySQL Docker images that we can get. We want Ubuntu, we want to run an Ubuntu image. There's Ubuntu here. There's, again, practically everything. MongoDB, anything, pretty much anything you want. In this case, we're going to do one that's called BusyBox. BusyBox is a very simple Docker image, and if we go on the page, there's also each page has kind of instructions on how to use this image. It has usually a documentation that helps you actually how to interact with that image. And as the BusyBox here says, the BusyBox is like the Swiss Army knife of like Ubuntu. It's a very lightweight Linux image that you can run. So I'm going to switch to my terminal here, and I'm going to show you guys how to use Docker CLI, the Docker command line, which is the main thing most people use. So one of the commands is Docker pull, and Docker pull BusyBox. You say the name of the image that you want to put. This downloads that image from Docker Hub into your repository, so on your machine. And now to see the Docker images that I have on my machine, so the cache images on my machine, I can say Docker images. And as you can see, I had some other ones previously downloaded, but you can see BusyBox is one of the ones that I just downloaded here. You can also see the size of them. This is another thing to mention why Docker is so good. This Linux image is only 1.2 megabyte. That's incredible. And you saw how fast it was to download this image. Now I show you how to run this image. So Docker run is a way to run an existing image. So it'd run a container on your machine from an image. So we say Docker run, and in this case, which container we want to run? We want to run BusyBox. I can use temp complete here as well. And what follows the container name is the command that now I want to run inside that container. So I say I'm running a BusyBox container, a Linux image container. And now what I want to do inside that container, let's say we just say echo hello Docker. So this echoes a command to our terminal. And if we run this, you see it printed hello Docker, which that command ran inside the BusyBox container. Now to see a list of running containers, there's a command called Docker PS. This shows you the list of running containers, active containers that are on your machine. If I do this command, you see there's no active containers because nothing is running. This container ran and it finished. one of the things to notice here, if you run Docker PS with a -a, which lists all containers, not just active, you see that the container, this contains a BusyBox container that I run with the hello Docker message, exited 37 seconds ago. And you see that these containers kind of linger around in Docker. So when they exit, they kind of linger around. One of the ways to avoid that is you can do Docker run with the -- remove option. So now we're giving options to our Docker run. And -- remove says remove this container after it has exited from our system. It has exited executing. So now we say hello again. And this time when I run this, I get the hello again. But if I do Docker PS -a, I don't see that container linger around because it was removed immediately. One of the nice Docker commands that I should show you guys is Docker system prune -f. This is a way to prune all those lingering images and containers from your system and just completely clean up your system. So when I run this, you see it deleted one of the old containers. And if I do Docker PS -a now, I don't see any containers listed. So it removed that lingering container. Now, let me show you another way to run Dockers, which with an interactive shell. This is a very useful way. So let's do another Docker. We do a Docker run. And this time, I'm going to give it the -- remove option to remove itself after it's finishing executing. I'm also going to give it a name. So name this container. If I don't do this, you see Docker just kind of makes up these names. It just assigns a random name to you. But in this case, we're going to say name this container terminal. And we're going to give another command line option, a run option, which is -it, is standing for interactive terminal. And we say BusyBox. So in this case, we're making a Docker container from BusyBox with an interactive shell, and we named it terminal. If I run this, now you see I go inside now I'm inside the BusyBox container and I have an interactive shell. So I can do ls, I can do any command here that, just your regular like Linux commands, and I can exit and this container just vanishes after that. Let's do one thing here. I'm gonna show you also another useful command, which I'm gonna start another terminal here and now do Docker exec -it again, terminal, and I'm gonna do bin sh. So what Docker exec is executing a command on an active container. So in this case, it's a little different from Docker run. Docker run starts a new container. Docker exec attaches to a running container and it runs a command on that container. So in this case, we named that container terminal. So we're running a bin shell, a shell terminal again on that container. So again, I'm inside the shell of that container, and I can do even something like echo goodbye blue skies to like test file.txt. So I echoed something to a text file. You see that file was created on my container. I can more of that and shows the content. Now, the interesting thing would be if I come back here on this shell, which is still I'm inside that container, you see I see the test file, and that's already here. Now, again, I can just exit, and that gets me back to my own terminal, and I can exit out of here. And if I do Docker PS -a, that container is gone now. Very, very handy. Another thing that I want to show you guys is to use Docker volumes. And remember now I want to show you how you persist things in Docker. But I also want to show you how to use Docker ports. So these are for applications or containers that actually expose a port to their host. Maybe it's a web server that serves, some files or some HTML files, and then that exposes that web server to the host machine, which is my machine here. So I'm going to pull another Docker image, which is the ng annex server. So we pull this image. And you see it's pulling layers. This is, again, you'll see this layer, but that's one of the really handy things of Docker, because it makes things in layers. So if you already have one of those layers on your machine, it just doesn't download that anymore. So it's a lot faster in that sense. So now, if we list our images again, you see nginx server what is included here, and we're going to do a Docker run. We do a Docker run. Let's name it, and we call it our server. A very handy command is -v option, which is to attach a volume to this container. I'm going to show you actually before that we do have a data directory here, and that data directory has an HTML page along with some names and over the text file. So I'm going to mount this directory to my server, nginx server, and make it to host this HTML page. So let me actually just look up this command really quick. Okay, I'm going to get this path here because it's just going to copy and paste this actually here and show you guys what this is. So I'm doing a Docker run. The -d option is to say to run in detached mode, kind of run it in the background. I named it nginx server. I attach a volume with my current directory data file, and I attach it at this location of the container. This is where my nginx server actually will host HTML files. My server will host the files. I attach it with read-only permissions. And the last one is the -p option in Docker run, which tells you that I'm mapping port 80 of my container to the port 88 of my host. So then my web server will host on port 8080 on my machine. And if I run this, it kind of runs in the background. I can see it running. And what's interesting is that I can come here and now say localhost 8080. And you can see that that is the HTML page that I have inside that directory. So this is being served from this container, and I can access it on my host machine. This is how you attach a local directory as a volume to a running container. We can also do something. We can also actually have Docker do this, do attach volume. So if I do Docker run -v, let's do the -remove again, -v, we just do data here. So it's not an absolute path, it's just a name. And then mount this to data directory of our container. And we'll just do the busybox again. Busybox and shell. So in this command, oh, I did not do it interactive shell. So I did the -it here. In this command, Docker actually creates a volume called data and attaches it to the /data of our container. So if I do ls data, it should be empty, but I can go to data, and then I can maybe echo something to a test file here. All right. Now, if I exit this, that the content of the data directory now should still persist in this data volume. So one of the things I can do, I can list my volumes with Docker volume ls, and you see that data volume was created. Now, if I go back and run another instance of this, so I'm running another container with the same volume attached on data in BusyBox, and if I ls my data, you see my file is there now. So this is a way to persist files in between Docker runs. Okay, we'll exit here. And now let me show you another thing in Docker, which is called Docker files. So in the code here, which we'll send you after this webinar, I have an image directory, and inside this image directory, there is Docker file. Docker file, if you remember, is the instruction file to build an image. And it looks like this. It has very basic commands. So in this case, we say, start from a Python image. So it starts from an image that already exists in Docker Hub. And that's our sort of root or source image. Then we add some things into here. So we add this names.txt file, and we add a main.py. So we add our own script, our own code. And if you see here, this main.py is just a very simple Python script that prints the content of name.txt to the screen. And after that, run that Python script. So this is a command. So run that script with python.main. And that's our image. So our image is gonna start from a Python image, add some files into it, and then run a Python script at the end. Now to build this, we use docker build command. Actually, well, I have to go inside that directory. And then we do docker build. We're gonna tag it with a name. So the name that we're gonna give it, first image, and say latest, the latest version of it, and build this directory. So build everything in this directory, and docker build by default looks at the Docker file and it just executes the instructions there. And you see that it downloaded the Python image, it added the files and build the image. So now if I do Docker images, I have a new image called first image, and we can do a run of this image. So we can do Docker run, again, minus remove if we want it to be removed at the end, and we'll do first image and run the latest version of this. And if I run this, you see it printed all the names that was in that file. So very easy way to pack code and files or applications inside a Docker image. Another thing I want to show you here is Docker Compose. So if we go to our Compose directory, this is an example where I have an application that has multiple containers. And if I come back to my code here and show you this, so I go inside the Compose directory, Docker Compose starts from a YAML file. That's the instruction file that tells Docker Compose what to do and how to orchestrate the different containers. In this case, we have 3 containers, one called DB, one called loader, and one called app. The DB is just a MariaDB instance, so it's a MySQL instance. The loader is a container that we would build ourselves from a Docker file, and it loads a list of airports. We have this list of the CSV list of airports in the United States into our MySQL database. And then we have another container, which is app, which is a Flask app, a Python Flask app that will host those airports as a REST API. So we can use a REST API to then view those airports. The really nice thing here is that I can do something as simple as Docker Compose up in this correct directory, which by default looks at that YAML file, and it runs instructions. So we bring in up a cluster of containers with this command. And you see it created a database, it created a loader container, and the loader container is loading up right now. And once the app starts, everything now started up, the loading finished, and it lists here that you can ping on that the Flask server is on this port. Now let's ping it. So we can use curl. Let me actually copy this. So that's the IP address of our container. So we do curl, and our REST API takes the IATA code off the airport, and so we query for PDX for an airport, and we can run this through Python 3 JSON tool, which pretty much prettifies the JSON that comes back, so it formats the JSON for us. Maybe I am, hold on, let me see if I'm running that command correctly. I believe it's, oh yeah, I forgot my -m here, of course, to run the JSON module. Oh.
I think it's JSON.tool.
Oh, JSON.tool. Yeah, there you go. So we actually pinged that container, passed it the PDX airport code, and it's given us back the information from Portland Airport. We can run it with another option. We can do Seattle here, and we get the Seattle Airport. And you see like our container. And once you don't want the cluster up again, you can just Control C out of Docker Compose, and that just automatically shuts everything down. After things are shut down, we can also run another command that is Docker Compose down, which kind of just clears everything out. So now we ran an entire cluster of containers and we brought them down, and they're done. It's very, very simple. That's it for our demo. Hopefully that was useful. We showed you all the basic functionalities of Docker. So you saw Docker CLI, how you can run containers, download images, how you can build your own image. And also we showed you Docker Compose, which is a way to orchestrate clusters of containers together.
And one thing I would add to this is that this demo is adapted from chapter 5 of our 10-chapter curriculum, the data stack course. So this is just sort of a small selection of what we spend a full week on with Docker. And there's a lot more details and hands-on coding exercises. So if this is of interest to you, we spend quite a bit of time on Docker in the course. So there's a lot more to learn.
Exactly.
Okay, so let's talk about the path to data engineering, how to become a data engineer. At DataStack, we're passionate about technical education, about data engineering in particular, because it's a great, very rewarding field, and there's a lot of demand for it right now. But there are a lot of skills to learn. So let's talk about some different ways to do that. So one of the paths is self-learning. This path is typically better for people that have some technical background, that already have some experience with programming or some industry experience. So one of the best things that you can do for yourself, particularly if you're on the self-learning path, is follow the cloud certification path and get some kind of cloud certification. All the major cloud vendors, Google, Microsoft, Amazon, have a number of different certifications at different levels. Different as an architect, data engineer, machine learning, different levels and different skill focuses. And those things are very, very valuable, obviously for your own learning and your own skills, but also in terms of employment and proving to potential employers that you do have those skills. Those can really help distinguish you from a crowded field of applicants. Another thing that we highly recommend is whenever you're learning anything, even when you're first getting started, make an account at GitHub, build a portfolio on GitHub. Whenever you do anything, even if it's something that seems like a small project, put it on GitHub, put it in a repository, make a README file for it, give a little bit of explanation. And that's great because it makes it easy for anybody, potential employers in particular, and people that you might be working with, to see what exactly you know how to do, what your skills and interests are. We like to say code doesn't lie. If you've written some code or an application that does something, or a tutorial that's using some existing code, make sure you put that on GitHub so it's visible to the rest of the world. Employers in tech, almost any employer, any job that you apply for at this point, your potential employer will go look at your GitHub portfolio and see what you've been working on. So that's one of the best things that you can do that doesn't cost anything, that will help you organize your learning path, and it'll make it easier for you to get a job. The other thing is tackle real world projects. There's a lot of great resources out there. Kaggle is a site for that's data science and data engineering focused, that provides a lot of amazing free data sets, tutorials. Data Hub.io is another similar site that has a lot of existing data sets. And there's in our notes for our slide deck, there's so many more of these resources that are free, that are easy to get started with, that'll really make it easy and fun to get up to speed with, whether it's learning Python, SQL, Docker, the different basic skills of being a data engineer. And it's so easy and so much fun, because there are a lot of interactive resources that really make it easy to learn. There's a lot of, depending on your learning style, there's some amazing things on YouTube. You can learn so much on YouTube, particularly if you're more of a visual learner. There's things like Twitch and other platforms for like interactive coding and coding along with other people. There's just, again, so many resources, and even though tech can be a little bit overwhelming, there's a lot to learn. It's amazing how much you can learn on your own for free if you just know where some of these resources are, and you invest a little bit of time to go and start teaching yourself, and you can have a lot of fun doing it too. In the self-learning path, there's also a lot of paid online programs that are sort of course-oriented. They're individual courses. So Udemy, DataCamp, Coursera, I think we've probably all heard of these at this point. Those are extremely useful resources too. You can learn a tremendous amount, and the barrier to entry in terms of costs on those is typically lower than with a boot camp. Those do provide some organized resources, but you also have to have some self-motivation with those to stick with the schedule, and you don't get as much hands-on time or any hands-on time with an instructor. But those can also be those less expensive paid online programs can be a really good resource as well. So the other main learning path that we want to talk to you about is boot camps, and that's what we're focused on here at Data Camp. Our course is a boot camp style data engineering course. So the advantage of a boot camp style course, one advantage is a focused and declared intention. I mean, a boot camp style course is a bigger commitment in terms of cost and in terms of time, but it also is very well organized. It's something that, the self-learning path can be hard because you're living your life, you have other time commitments, and it can be hard to structure your time in such a way that you really make steady progress and learn all the things that you need to. And the bootcamp model really helps with that. Another big advantage is the collaborative aspect in coding with others, because when you go get a job in the real world, you're not just going to be working with yourself. You're going to be working with a team. You're going to be solving problems with a team. You're going to be writing code with other people. And that's a big part of what the advantage that a bootcamp provides you, is that there's a big hands-on component and a big component of doing real world exercises with other people. Another advantage of the bootcamp style that's hard to overstate is that it's instructor-led, and the hands-on time with an instructor. At DataStack, it's a full-time 40-hour week course with lecture in the mornings and exercises in the afternoon, and you get many hours of hands-on time with an instructor who gets to know you over the period of the class and know your needs, know how you learn, that can answer whatever questions you might have. And that's the advantage of that is really hard to overstate. Another big advantage with boot camps, and something that we provide at DataStack, is career services. There's whatever your path is, there's a lot of opportunities in tech, but it can be really intimidating and overwhelming, especially when you're trying to get that first job and you don't have a lot of experience, or maybe you're changing roles in mid-career. So the career services aspect is something that is a big value add in the bootcamp model. So at DataStack, we provide we guarantee internship placement and to help you get that first hands-on position. And that career services aspect is, again, something that's hard to reproduce elsewhere. And career services and boot camps are very focused on the exact type of job, the exact type of company that you're going to be working with out in the real world. Obviously, with boot camps, the time and monetary cost and commitment is higher. So, like with anything else, there's a trade-off. Boot camps aren't for everybody, and for some people, the self-learning path can be very, very productive. but we're passionate about technical education, and we provide a boot camp for a reason, because we think that focused intention and that investment of time is incredibly valuable. And so, we've developed a curriculum that we think is really second to none anywhere else. And we'll tell you in a little bit about how to find out more about that. It's part of our couple of chapters of the curriculum for free, and how to find out more about our course.
Yeah, thanks, Guy. So quickly about our curriculum, so about our bootcamp. So you can find us at datastack.academy. That's the URL. You can also go to datastackacademy.com. Like guys say, there's a lot of good resources there. One of the biggest resources, there's plenty of links there that says get started for free. That actually downloads the first 2 chapters of our course, which is Learn Teaching Python and SQL. And in those 2 chapters, you're going to do 3 big projects. I think there's over like 30 or so examples or practice exercises. You can build a lot of those on GitHub. So that gets you a really great head start on your building your GitHub portfolio. I would highly also recommend, if you want to talk to us, there's a link that actually puts a calendar meeting on my calendar, so that you can get to talk to us one-on-one. If you have any questions, we would love to talk to you and talk more about the boot camp. Like Guy said, we're very, very proud of the content of this boot camp. It's geared to get you a job as data engineer and teach you the latest modern technologies in data engineering. You can see that it's 10 chapters. You can see the list of chapters and list of the skills that we will teach you, or the tools that we teach you. But I think the difference here between us and other platforms that are out there, that we've really taken a cloud first mentality to our course. So we teach you all these skills on the cloud, and we think that's very important for you getting a job, because let's face it, everything's moving to the cloud these days. And if you're not on the cloud, you're just on stale technology, or technology that's going to be very stale very, very soon. So that's one of the main differentiators, I would say, for us. We've chosen Google Cloud for our course, and the reason we did that, because Google Cloud, we think it's the closest to the open source technologies, to the underlying open source technologies. And when you learn those, it's easier for you to kind of go to the other clouds. So it would be easier for you to transfer that knowledge to Azure, AWS, or Alibaba, or other clouds that are out there. That's pretty much it. Hopefully this was useful to you guys. I know we ran actually just on time, as much as what we wanted to run on. But hopefully you guys got to learn some basics of Docker, why is Docker used, and some basics of using Docker CLI, using Dockerfile, using Docker Compose. I know a half-hour demo is probably very tight for a lot of those, but we try to fit as much as we can into that. So if you guys have any questions for us, Guy and I are going to stick around for a few minutes. I really invite you guys to go off mute, ask us any questions that you have. Please engage us. And you can ask us about Docker, or you can ask us about anything. You can ask us about DataStack Academy. You can ask us about data engineering. We are passionate data engineers. Yeah. We love talking about it. Don't be shy, guys.
All right. Okay. I'm going to ask. So for this program, I don't really know what is the money cost for the program.
If you go on datastack.academy, we list the tuition. There's a lot of options. So we actually partnered with a very well-established existing partner called Epicodus in this one. All the admission would be mostly towards handled by them. There's a heavy discount if you do want to pay up front. I believe it's $7,800. Again, it's managed by them. And if you want to, there's a lot of financing options that they do provide. The financing options anywhere from a loan. There's tons of loan companies that we work with. they work with. There is, and I think for a financing option it would be, I think it's 11,000 something, 11,700 or something. Yeah. And that's I would say towards the, again, a much more affordable sort of budget on boot camps. These boot camps, technical boot camps, I'm sure you're aware of, range anywhere between, again, that 9,000 to, I've seen 30,000. So this program that we offer with our partner is budgeted, so make it accessible for as many people as want to take this. It is a 20-week long project. So I believe there's 3 weeks of intro to coding that actually our partner of the Codis will run, and then our curriculum, which is the chapters that you saw, that is 17 weeks long. And we go straight to it. We teach you everything you need to know pretty much about data engineering, and it's very condensed, very informative, a lot of tools and technologies. And actually, Guy is our instructor. So you will get to talk to Guy every day. You will talk to me every week, more in the mentorship role. I'm the mentor for the program.
Yeah, and it's, we've done the best that we can to just put as much useful information as we can into this curriculum. I mean, it's something that outside of a boot camp, that if you were learning on your own, it would take you many months and years to learn in a different way, really years. So we think that it's it's a really good return on investment for people who are willing to commit to it. And we've spent a lot of time and energy developing this curriculum that we think is really not available anywhere else.
I think the key point is like that job first mentality. So I mean, we've made this, and we guarantee you, if you learn everything in the course that we teach, you will definitely have a very high paying job in data engineering. And we do place you in internship as well. I think that's very key to notice. So as part of the graduation, you have to do a mandatory 5 weeks internship with one of our partners, one of our data partners. So these are large companies that host interns, large data companies. And that's a great way to get real world experience, get your foot in the door. And then from there, with your knowledge and the internship experience, hopefully, you will be able to get a job fairly easy.
All right, that's good.
Yeah, thank you. Hopefully that answered your question. I know
Yes.
We love talking, so we always go talk a lot more.
Yeah. So, all right. Like, is it possible? I don't know. But is it if you can reiterate like the companies where someone could do the internships? I don't know. You said these are how many weeks? I don't know. Converting it to months. That should be. I mean, like how many weeks? Maybe I missed that area concerning the
5 weeks of
internship
you will do 5 mandatory weeks, and that, yeah,
5 weeks.
5 weeks that's mandatory that you have to do to finish the course. Yeah, with the internship. Of course, I mean, you can, there'd be option to extend that if you like with the company, but for us to say you've graduated, you have to do at least 5 weeks. Yes.
Oh, that's a month.
With
Roughly a month, right?
Yeah.
So just the big picture is you have 3 weeks of intro to programming, and then the data engineering curriculum proper is 17 weeks, and then at the end 5 weeks of internship. So it's the 25. Yeah, 25 weeks altogether.
Well, actually 27, because we also then do 2 weeks of career services.
That's right. Yeah.
27 weeks. Career services is really to groom your application, your resume for jobs, and help you one-on-one to like which jobs you should apply based on your skills, and kind of mentor you through that as well.
That's cool.
Yeah, this is again, if you go on datastack.academy, I think all of this, all of this is listed there. You can again review them there as well. Everything that we pretty much said. And then some of the companies that we've been signing up are also listed there. Some of the companies that would host the internship.
All right.
Again, that's a subset. We have plenty more, but that's a subset of companies that we've signed up.
All right. Thanks.
Mm-hmm. if you are interested in data stack program, I would highly recommend, on the website, there's a schedule a call link towards the bottom of the page, and you see my picture actually there as well. That goes straight to my calendar. So I'm available. I'm even available next week. I'm available anytime you like. Put a time on my calendar that works for you, and I would love to spend one-on-one with you and talk more about it. And I'm sure you have tons of questions, and you can compile all your questions, and we will talk about it.
Yeah, we know this sort of thing's a big decision, but we're here to help.
Yeah.
Okay, yeah.
And again, I'm
All right.
almost available all the time. I'm not taking holidays this holiday either, so anytime I should be available. That's available on my calendar. Yeah. Cool. Well, with that, I think, are there any other questions, folks?
That's all for me. Thank you.
Yeah,
Thank
thank
you.
you. I appreciate it. Yeah, thanks for logging in and staying with us. We really appreciate it.
Claude, did you see the ones that we had in the chat?
Oh no, I do.
Oh, yeah,
I
let's
closed
check.
the chat. Yeah, let me go over to chat now.
Okay, cool.
Great.
And I added, for anybody who's interested to view the curriculum, I have our GitHub link there, and the first 2 chapters are free to review.
Okay.
Okay, so I'm just gonna kind of going from bottom up. So sorry, I will get to your question. One of the question that I see is question regarding Python. Is knowing Python the basics for our course? Do we need Scala for like, or actually for data engineering for Spark and Kafka? Our course is all on Python. So to do actually our course, you don't need to know Python as much. We do highly recommend that you go out and do some of the self-learning sites of Python that are out there, and there's plenty out there. We will teach you the basics of Python for data engineering. I would say data engineering as a whole, Python versus Scala versus Java versus Go being another dominant language there, we highly recommend Python, and we've kind of chosen Python, even though Guy and I pretty much know all the other like Scala, Java, we know them. We say that because Python is much more lightweight. It runs a lot easier on the cloud. It doesn't need, something heavy like a JVM as like Scala or Java do. And it's a language meant for data engineering. It's a language to do data massaging, data transformation. And it's just, it runs so much easier on the cloud. And the other reason is that it's a Python package manager, pip. So it's very easily to install other packages that you would use in data engineering, like pandas and all these other, packages. And it's a language between data science and data engineers. So those two fields are really married together almost nowadays. So data engineers and data scientists work together. Data scientists heavily use Python. They prefer Python. So we also recommend as data engineers to be heavily on Python, and there's a lot of great programs on Python. So I mean, Spark has, PySpark, which is the Python interface to Spark. There's Airflow, which is orchestration too. That's also Python based. It's just, I think over Scala, Java, Go is also one of my favorites too, but out of those, I would still highly recommend Python as the starting point. And it's as far as like the percentage of use. So when you see actually the reports like DICE report, the 6 million analyzed jobs, Python was at #1 in those languages by a very decent double-digit margin still. So it is much higher use than actually those other programs right now. Did that answer your question, Kelvin? Did I read your question right with Python versus kind of Scala, other things? As far as the technologies, you're dead on, and those are technologies that we use. So like Spark, yes. Kafka, yes. I would add Airflow, Docker to that list as well. Okay, another question that I see is, have issues with my mic. What is the new technology tools you should learn if the data engineering wants to become next level? We say, so if 5 tools to learn as a data engineer.
Right.
Well, let's simplify this, because that question that you said, what are the tools that you have to learn as a data engineer? If you ask any data engineer, you probably get a list of 100 different tools at the end. There's a lot of opinions there, but here are the 5s. Like, your basic is Python and SQL and shell programming. I would call this as a basic or as one, because that's just the basic. SQL, Python, terminal shell programming. I would actually say Docker and Kubernetes as the next. And these are, again, backed by that DICE report that I'm talking about. So they analyzed a lot of jobs, and these were the top skills there. After that, learn Spark. Spark is, again, the biggest big data tool out there, the #1 data tool. You don't really need to know all the intricacies of Hadoop and MapReduce and none of that. Just learn to use Spark. Yeah. Kafka as a streaming and orchestration platform. So anything that data streaming and a backbone of the real-time data processing is Kafka. And 5, Airflow, Apache Airflow for orchestration. And I would say learn these 5 on the cloud. So each one of the cloud vendors have a version of these. They might call them something else, but on their cloud, there's one of these services. Learn these on the cloud. Learn to use them on the cloud. That's key.
Yeah. And it's, there's so many tools out there, and every company has a little bit different stack. But that list that Param just gave you, it's hard to go wrong with those things. If you have a good working knowledge of those technologies, there will be so many opportunities, so many companies that will be eager to hire you. And we've developed our course around that, and we think we put as much into the curriculum in 17 weeks as we possibly can, and it's it'll give you not only a good basis, but give you the skill set to be, again, highly in demand. But those 5 are, it's really hard to go wrong with that list. Yeah.
I mean, yeah, and I would say even like probably 3 out of those 5 would get you probably a pretty decent job. But if you know that 5, you're a very wholesome data engineer. You've known everything. The basics, containerization, Python, SQL, the containerization technologies. You can take that knowledge to any cloud. You know how to scale things up with Spark, so you know how to run data pipelines at scale with Spark. You get to learn the real-time data processing, which Kafka brings, and orchestration, which is the Airflow. So then you're well-rounded data engineer at that point.
Great. Yeah, and we'll be posting the video recording and also a link to the slide deck. There's plenty more notes and resources in the slides. So yeah, check that out. Check the recording out, especially if you didn't get to hear the whole thing. And check out the website, book an appointment to ask any questions you might have and get some mentoring. We're glad to help in any way we can.
Keep a lookout on the email that you use to register for this webinar. You'll have an email from CJ with the recording, the slides that we use with the slide notes and all that, and even the code. So the visual, the code that I used, we can host that, and you'll have that as well. Perfect.
All right. Thank you.
Thank you so much, everybody.
Yeah, thanks. Appreciate it, guys. All right, with that, we're gonna cut it here, and hope to talk to you guys soon. Take care and have a good
happy holidays.
Holidays, yeah.
Bye.
Take care. All right.
Nice, that was great. We had several new people.